Hello, good morning, everybody. Okay, welcome again to the final push part two, and this is really the final push because this should be the last session before your exam on Monday. All right, so we are going to be discussing a few paper two questions that I've selected. Well, they may not be the most difficult, but I feel that some of them are very interesting, okay, and they would evoke certain questions that will lead to a healthy revision, okay, of the topics. So here you have the topics for your syllabus divided into 5 topics. So as you're joining in, good morning, all right, and please, I hope that you will use your real name so that I know who is responding, all right. Number 2, please participate. Okay, number 3, if you have questions, please put in the chat. All right, so we are going to start now. Okay, have a go at this question. Yeah, 2 stones, they fall of different heights. I think they fall from the same height. Okay, and what do you think will happen? So these stones are of different sizes, so different weight, and they fall at the same time from the same height. And what will happen? So this is a simple question to get us started. Can I see some answers? Okay, yes. Right. Okay. Correct. So the answer for this question is A. So remember, when they ignore air resistance, regardless of the shape and the size, all objects that are dropped by from the same height will reach the floor at the same time. All right. So very good. Very good. Let's move on. Aha. So another question that will really test your understanding on mass and weights. So for general physics, you will have a lot of questions that are very, very close like that, right? So do let me know what you think the answers are. Okay, Dion says it's D. What about the rest of you? Ian A, huh? Kenjin A. All right, let's have a look. All right, look. Definitely for in this question, the answer is A. Okay, look. Um, well, this steel block balance measures the mass. All right. So the fact that they are at the same level, it means the mass is the same. All right. But you all have learned, right, that mass, okay, they are always constant, but weight they may change. So many students will choose B. Okay. Many students will choose B, but they are in the same place, they are in the same room, and they are next to each other. So in this case, the mass will equal to the weight. So the answer is A for this question. All right, so we'll move on. Huh? Okay. I think the column on the right shouldn't be a problem. I think all of you all know the water level. But what about the measuring cylinder that you should use? Can I see some answers? Now, okay, remember, of course, this is not really, that's why I chose this question, right? Yeah. Uh, but remember, in physics, right? Whenever it's not necessary to use a larger measuring cylinder, all right, we or whatever apparatus that you're using, you use the one that is just nice for the quantity that you want to measure. All right, so you are measuring 40 centimeter cube, so you have a choice of the 50 centimeter cube measuring cylinder and the 100 centimeter cube measuring cylinder. It makes sense to use the smaller one. So the answer is C. Yeah. So I hope you learned something there. Okay. Yeah. So whenever it's not necessarily to use something that's an apparatus that's so big, we don't. All right. In physics, we don't. Okay. We just use the one that is suitable for the quantity, for the magnitude of the quantity that we are measuring. So in this case, the answer is C. Interesting question, right? Interesting question. If you got this in the exam, I bet you'll be stuck. Like, what should you do? Are you kidding me? Now the the object is experiencing air resistance. Okay. Now as you fall, as the ball moves down, all right, as the ball moves down, you need to understand that as the ball goes down, all right, initially it looks like this, okay, but after some time, when the ball is much lower, okay, the weight stays the same, but the air resistance increases, right? All right. Yes. Hello. Thanks for joining. I see some new faces. Yeah. Thank you. Please participate. Yeah. Junsi, don't be funny, please. Okay. All right. So in this case, so the air resistance is increasing. So when the air resistance is increasing, the resultant force becomes smaller. Of course, in this case, the resultant force is zero lah, because the length of the arrows are almost the same. So guys, yeah, as the ball is falling down, air resistance increase. Now, if air resistance increase, the resultant force becomes smaller. And when resultant force becomes smaller, acceleration becomes smaller as well. All the way to zero if terminal velocity is reached. Okay, so the answer for this question is A. Because air resistance increase, resultant force will become smaller. And because resultant force becomes smaller, acceleration becomes smaller as well. I hope this is clear. All right. Aha! I'm very sure a lot of you will get this wrong. Sorry, that's very discouraging. I'm sorry. Yeah. Please think about this question and yeah, please think about this question and let me know what you think. 加 en c. Yeah, I mean, really, it's quite. I think this is a quite a practical question, right? Whenever you want to cut a piece of paper, or whenever you want to cut something that's more difficult to cut, I'm sure you will position the object at Q. Yeah. Hi, Jared. Good morning. You just came, is it? Yeah. Now, but let me explain scientifically. Okay. Now, this is the pivot. Okay, and you have your scissors. Okay, now here is where you apply your hands, right? Okay, your hands will be there. Now your hands, you know, you will put it in a position where you will use the least amount of force, because humans, we all want to be comfortable, right? We don't want to work too hard. So you will place the your hands in a position that is that is furthest away from the pivot, because the further you are away from the pivot, the smaller the force. So you will put your hands in position S. All right, so remember, the further you are from the pivot, this is the pivot, right? The further you are from the pivot, the less force. The nearer you are, the more force. And the object you want to cut, the object that you want to cut, I'm sure you want to apply the most force, right? So if you want to apply more force, all right, if you want to exert more force on the object, I'm sure you want the distance to be small, correct? So Q is where the distance to the pivot is the smallest, so the force is the greatest. Okay, now P will be, yeah, sorry, let me just put this as pivot so it's not confused with this. Now P is furthest away from the pivot. Okay, now as you're further away from the pivot, your force becomes smaller. That is why you put your hands at S and the object at Q, and that's why the answer to this question is D. Any questions? Please ask. Any questions? So this is I find this is a very good question. I like it so much. Yeah. So further, yes, Kenjin, further you are from the pivot, of course, because moment is force times the distance. So the further you are, less force. All right. The nearer you are, more force. Okay. Moving on. Aha. One of my favorite questions. What do you think? I bet some of you are saying, teacher, we actually need to print this out, we need to draw it, we need to measure it. Not necessarily, okay? Not necessarily. Let me see, Ian. Okay. Now, I think it's important for us to know that the answer is not D. The answer cannot be D, okay? Because to achieve 20 newtons, you would need 10 newtons and 10 newtons, and they need to be parallel. They need to be parallel in the same direction, then you get 20. In this case, the two 10 newtons, they are not parallel, so definitely D is out. Okay, now maybe what we can do is we can draw the resultant force. Okay, now look here. So they have drawn the parallelogram for you. So you know that this is the resultant force. So if you had that question on you, this will be the resultant force. Now tell me, is that resultant force longer than 10? It is definitely longer than 10, right? Because you must understand that this one is a vector topic, right? So the length of the line represents the magnitude, the size, okay? So the length of this line is definitely longer than 10. So the answer is not 20, all right? But it is longer than 10, so the answer will be 18. So I hope this is clear. If you have any questions about this topic, please let me know in the chat. Okay, any questions? So the answer is C. Now let's move on. Okay. This is on pressure. Pressure and force. You know that pressure and force, they are very closely related. What do you think? Let me know. Think carefully, think hard. Okay. Now, A, B, okay, A, B, C, and D. Okay, guys. Now, I hope that you know that pressure, liquid pressure, all right, depends very much on depth. Okay, and force depends very much on the surface area. So since the pressure is the same, sorry, since the depth is the same, so the pressure, okay, will be the same. All right, so the pressure, so D is wrong. Okay, now since the pressure is the same, so D is wrong. Okay, so C sounds like a very good bet. Okay, now I would have you know that X, the surface, is larger than Y. So X here experiences more force, and Y here experiences less force because the area is smaller on Y and the area is larger on X. So X experiences more force and Y experiences less force. So B is wrong. Okay, and of course A is wrong as well. So the correct answer is C. Hello, I see we got new friends. Hello, Elisa. Yeah. So the answer is C. I repeat, yeah. So the depth is the same, so pressure is the same. So C is a very obvious answer. But sometimes they would need your understanding on force as well. So force depends on the surface. All right. So since X has a larger surface, so X experiences more force, right? There was one question that came up before, all right? Let me not really digress, but yeah. Okay. So they had liquid level at A and liquid level at B. Okay. So then, can you compare the pressure, all right? Um, okay, the pressure at the bottom of the tank, okay, when the water level is at B and the water level is at A. All right, so of course when the water level is at B, so the pressure is greater than A. But what about the force? Okay, now the force on the surface, okay, of B. The force on the surface of B is greater than A as well. Why? Because the surface, okay, the water surface of B is greater than the water surface at A. So, sorry, long story short, pressure, you look at the depth of the liquid, and force is the area. Alright, so we'll move on. Alright, we have moved on to thermal physics. Let me know what you think. So you will need to know that conduction, okay, usually happens in metals, solids, right? And convection happens in gas and liquid. So you heard me mention, yeah, you heard me mention um, solid, liquid, and gas. Okay, so you need to understand that conduction and convection. You need to understand that conduction and convection, all right. Now, both of these require matter. So when we talk about matter, we talk about particles, all right, of solid, liquid, and gas. So immediately when you see that there is a vacuum there, conduction and convection does not take place. So immediately you know the answer is A. Okay, so remember, conduction and convection, they need solid, liquid, gas particles in order to transfer the heat. But since it is vacuum, all right, there will be no conduction and convection happening. All right. Now, what radiation is that, guys? What is another name for thermal radiation? Can you put that in the chat? What is another name for thermal radiation? Correct. Okay, so you have infrared radiation. Now, infrared radiation, you will realize that does it need a vacuum to travel? All right. No, right? So infrared radiation, just like the entire spectrum of electromagnetic waves, they do not need a medium to travel. Yeah. So that's why the answer is A. I hope this is clear, right? I hope this is clear. Moving on. Okay, and of course, this is always a challenge for many students because a lot of them can't grasp the concept of responsiveness, range, sensitivity, and linearity. So give it a go. All right, how's my drawing? Huh? These are the bulbs, and one of it is narrow, okay, and one of it is not so narrow. So you have here P and Q. Did I represent them correctly? Chia Ian, A. Okay, P and Q. So P has a smaller diameter than Q. Okay, now they have the same volume of mercury. All right. Um, Immediately you know that if you heat them up, all right, which thermometer will reach the maximum limit sooner? Of course, it is P, right? That means the range of P is lower. Let's say it can measure 50 and let's say this can measure 100. All right, because at 50 degrees, P would have no more space for the mercury to expand. Okay, whereas Q, there's more space for the mercury to expand. So therefore, you will know that the answer is C or D, right? Okay, so greater range belongs to Q. What about sensitivity? Sensitivity, so range would mean the difference between the highest and the lowest temperature in the thermometer. Now, what about sensitivity? That means each degree Celsius, what is the distance moved? Each degree Celsius, what is the distance moved? The greater the distance moved, the greater the sensitivity. So, of course, being narrower, the sensitivity is greater. For example, let's say this is 20, this would be 21. All right. In the and in this case, let's say this is 20 and 21 will be much closer. Therefore, we say that the sensitivity of P is greater. So the answer is C. So this is a very students find this topic very difficult in thermal physics. Okay, from my experience, I know. So I hope this has helped you a little better in your understanding. All right. So we'll move on. So this is a very clear-cut textbook question. In fact, usually you get this question in the last topic. Absolutely right. I see the answers coming in. So the answer is A. Remember, temperature does not affect the half-life of a radioactive isotope. Thank you. Ian, Dion, Kenjin, Angsin, very good. So yes, half-life cannot be used. Radioactivity has nothing to do with temperature. You've got to remember that. All right. So number 2 is A. Moving on. So the rest of you all who are watching, please also respond with your answers. Okay. All right. So in refraction, which property remains the same? A very textbook question, but very important as well. All right. Yes. Okay. So remember that in refraction, frequency remains the same. Frequency remains the same. So this is also A as well. Frequency does not change. Now listen here. So we have the formula V equals to F lambda. So can you imagine the wave going into shallower waters? All right, you will see that the wavefront the wavelength will decrease. Now, since frequency does not change and wavelength decrease, so the velocity will also decrease. All right, so it's based on this formula. Okay, so when frequency is constant, we look at the relationship, the proportional relationship between velocity and wavelength. Well done. Moving on. Aha. So this will really test your understanding on the lenses. What do you think? Can I see more answers, please? Are you serious? Yeah, look, you need to understand something, guys. Okay, now f is the focal length. All right, now if you place your object here, listen carefully, please. So if you place your object here, you're going to get a virtual image. All right, and the image will be here, right? So that's the magnifying lens. Okay, now I would have you understand that if you put the object here in the region of B, you are going to get a very large image of B. So no, if if you want, yeah, and if you put your object at 2f, you're going to get the exact same size at the exact same distance away from the lens. So you would know that if you want a smaller image, you would need to put your object further than 2f. Anywhere further than 2f, you will get a smaller image. The further you put away from 2f, the smaller the image. So the answer for this question is A. It's not, many of you put B. It is not B. Alright, it is not B because in B, you are within the focal length and the double focal length, and that is the region that will get you a larger image. I hope this is clear. I hope this is clear. So as if you really want to do well for paper 2, right, you need to know that wherever you put the object, you need to more or less know what the image will look like. All right, you need to know that. Moving on. Not a difficult question, but it will really test your understanding. Any questions, please put them in the chat. All right. Seems like a lot of you have a very good understanding of the you have a very good understanding of total internal reflection. All right. So remember, it happens. All right. So it happens in the denser medium. Right. Let's do a quick revision on total internal reflection. Yeah. So it happens in the denser medium, and it happens when the ray is moving towards the less dense medium, and it happens when the incident angle is greater than the critical angle. So I hope you know that this is the explanation for total internal reflection. So it happens in the denser medium, and that is why the answer is C. Well done. Moving on. So we are already in topic 3. So we are more or less halfway through. Okay. Can I know what you think? Ian, can you explain why you think the answer is A, Ian? Or any of you, why do you think the answer is A? Anyone can give me an answer as to why you think the answer is A? Ultraviolet is also next to visible light. Okay, so yeah, the electromagnetic wave spectrum. So the first one is radio. The next one, micro. Okay, can you all beat me to writing this? Can you see? Let's see who types faster than me writing. Infrared radiation. All right, visible light is what we're going to be talking about. UV ray, X ray, and gamma ray. Okay, so radio, micro, infrared. Did I miss out anything? Okay, so invisible light, you will know that going in this order, it is the order of increasing frequency and decreasing wavelength. All right. So for visible light, the first one is red, and then you know the Roy Gabif, right? Orange, yellow, green, blue, indigo, and violet. So coming from the sun, guys, listen here. The sun does not emit everything, yeah. Okay, the sun does not emit everything, yeah. At the very least, it emits infrared right up to UV. So the sun emits infrared right up to UV. Why? Because you know, when the sun is up and you stand in the sun, it's hot, right? So you know that there's infrared radiation. And where else does UV light come from? We need to put our suntan lotion, right? When we are at the beach, isn't it? Yeah. So you will know that infrared is just before red. So the answer is A for infrared. I hope this is clear. All right. Moving on. Okay. Just a thought, right? As you all are attempting this question can be simple. Can someone please help me? Can you please, in the chat, write down the three characteristics for all electromagnetic waves? Can someone please help me by writing down all the three characteristics of all electromagnetic waves? Can somebody help me to do that? Please participate. Fantastic, Ian. Fantastic. Um, okay, looking at this current question now, uh, let's look at A, B, C, and D. Yes, A is a rarefaction at this point in time. So earlier there was a compression and later there will be another rarefaction at X. So A and B, they are both correct. Now it's only C and D. Okay, so you know the transverse waves, the vibration, in this case, the vibration is in this direction, right? It's in the horizontal motion. Why? Because the compression and rarefactions are like that. So you will know that the vibration is like that. So the wave is either traveling here or the other way around. Okay, so it's horizontal. Okay, so this is the vibration and this is the travel. Okay, so therefore D is wrong. So it is the answer lah, because it is not correct, right? So D is the answer. All right, that's how you find out the direction of the wave travel. Okay, all right. Moving on. All right. What do you think the answer is for the next question? Absolutely right. Absolutely right. So remember that wave fronts, all right, they are drawn perpendicular to the direction of the wave. So the wave fronts are drawn like that. Remember, they are perpendicular to the wave, and the wave fronts are drawn like that, perpendicular to the wave, right? So the answer for this question is none other than C. Well done. Well done. Well done. Okay, so I hope more physics student will be typing your answers like Jared, Junsi, Adam. Are you all here? Moving on. Okay. Haha. Yes, Carl, please participate. This will take some time, yeah? For those who have not participated, can you participate? Can I see some answers? Okay, this is taking quite some time. Are you there? Okay. So what is strange about this question is that the refractive index is less than 1. Alright? It's less than 1. So what should we do here? So start by writing the formula n equals to sine I over sine R. Alright? Now you will know that when you enter the block, the ray will bend towards the normal, and this is essentially the angle that you are looking for. That I've shown you, that's the angle that you're looking for. So all A, B, C, D, they are all plausible answers because they are all smaller than 62. All right. So apply the formula. What do you think? Well, no one is typing anything. Looks like I have to do it, yeah? Okay. So since the refractive index is 0.68, you put the smaller angle, on top, and this is the smaller angle. So sine R over sine 62. So remember, when the refractive index is smaller than 1, you put the smaller angle on top and the larger angle at the bottom. So but you need to find out which is the smaller and which is the larger angle, and to answer that question you will need to have a basic understanding of the refraction of light. So as you're entering from air into a plastic block, you bend towards the normal, so the angle there is smaller. Can somebody calculate for me what would be the answer? What is R then? Yes. So the answer is C. Well done, Jared. Well done. Yeah. So I hope this is clear. Okay, I think you all were a bit quiet in this question. So if you have any questions, please put them down. We are in the fourth topic already. Wow, Ian, that was quick. All right, all right. Now, yeah, thank you for participating. Now, you all need to know. Yeah, I want to do a revision on magnetizing, and it's a very common question. It comes up almost all the time. And demagnetizing. Okay, so here you have striking it, you have heating it up. All right, can you think of another way to demagnetize the magnet? How do you demagnetize a magnet? Yeah, you use the AC current, okay, in the coil, right? What about magnetizing? How many ways can you think of? For magnetizing, how many ways can you think of? Can you list down all the ways of magnetizing a magnet? All right, Elisa, can you write them down? Wow! Ian, you came up with the most difficult one. Stroking, DC. Okay, that's very good. Yeah. Uh, okay. Do you need me to explain what is stroking? All right. Maybe I give you all a small little uh, question on stroking. Okay. So you have here a steel bar, and you have here a magnet, and the magnet is moving in this fashion. What would be the polarity at A and what would be the polarity at B? Can you quickly type it down? A is what, B is what? Or just any one of them will do, because if A is north, B is south, right? So tell me what you think the polarity of A and B is. So please type A, what is it? B, what is it? So this is the stroking method, yeah, the stroking method. Any more? Yes, Dion, that's not right. Elisa, you are absolutely right. So this will be S and this will be N. Look, at this stage, you need to find a way to remember this. Okay, use your own way. You got to find a way to remember this. But I'm telling you that that's the answer. All right. A is S and B is N. Let's move on. Absolutely right. So immediately let's look at A, B, C, and D. Yeah. So immediately B and D is wrong because only electrons move. Only electrons move. So proton doesn't move. Neutron doesn't move, only electron moves. So with that, you know that you have narrowed down the answer to A and C. And if the rod is negatively charged, so the cloth is positively charged, so the answer is C. So anyway, I chose this this question just because I wanted to remind you guys that only electrons are transferred. Okay, I hope that is clear. Huh? Moving on. All right. Another simple question, but I hope that you all don't get this wrong. Let me know what you think. Okay, so you know that yeah, it comes from the word ferrum, ferrum. You know that iron in chemistry, right? Iron in chemistry is Fe. Okay, so it's actually ferrum in Latin. Okay, so in English the adjective is ferrous. So I would have you know that iron and steel is an alloy where the main component is iron. So steel is also largely iron and iron is iron. So the answer is A. They are both ferrous. Did anyone learn something new over there? Okay, you make me feel that this is a question that's too simple. Right. Okay, we haven't done rectification yet. So let me know what you think the answer is. Yes, Kenjin. Ferrous. Anything that has iron is ferrous. Yes. Okay, so yeah. So the answer is A, yeah. Sorry, Angsin. No, it's not B. It's A. So I'm going to illustrate A and B, yeah. So this is A. So A is actually an example of half wave rectification, yeah, half wave rectification. So basically it allows current here only one way, yeah. It does not allow current the other way because the diode is pointing in the opposite direction. Okay, so half wave rectification looks like this. So you have this, and in this half cycle, now the negative half cycle, you are not going to have anything at all. Yeah, so it looks like this. Now look at B here. Look at B. Now the issue with B is that it allows current to go both ways. So if current wants to go this way, it is absolutely fine. If current wants to go the other way, it is also absolutely fine. So current moves both ways. So that is not rectification. That is not rectified current. So that's why B is wrong. Rectified current means current that moves in one direction. So the answer is A. So I hope you learned something there. Alright, if you have something to share with us, also please use the chat and share with us. Yeah, don't be shy. Moving on. Okay. Ian, can I get another person's answer, please? I mean, it is very clear cut, right? I mean, B is like a free giveaway, isn't it? Yeah, so the answer is B, guys. Why would you think the answer is C? Okay, I think I know why you think the answer is C. Because, guys, this is a parallel circuit. Okay, this is a parallel circuit. Now, in a parallel circuit, right, if this is 12 volts, this is 12 volts, this is 12 volts. If you have another branch, it is 12 volts. If you did not choose B, that means you would think that if you have another component, the other component will get less than 12. No, alright? Because this is a parallel circuit, all components that are connected in parallel get 12. So which is why if you understood that, very clear cut, the answer is B. Okay? Now, so the answer is B. Are you all clear? Alright? Anyway, for C and for D, right, I need your help. I need you to tell me what is the correct voltage. So in the chat, can you please type down C, what is the voltage, and D, what is the voltage? Is it 0? Is it 12? Is it 6? Is it 1? Is it 2? So for C, it means that this is not connected and this is connected, right? So what should the voltage be? Yeah, correct. So this will be 12. Okay, because this is not connected. So what? If this is not connected, it doesn't matter. Every branch gets 12, right? However, if S1 is closed and this is open, all right, then yeah, the circuit is not complete and you will get 0 volts. I hope this is clear. Thank you very much. Moving on. Can anyone tell me what phenomenon is this? What phenomenon is this? There is a name for this phenomenon. Can you tell me? Can you type it in the chat? What do you think this phenomenon is? Correct. It is electromagnetic induction, which means that EMF is induced. Meaning that, we get kinetic energy being transformed to electrical energy. I hope this is clear. All right, let me know what you think the answer is. Okay, so that seems very easy, right? Okay, so my next question is this. All right, if the okay, I'm going to type my question down. So now, the wire moves away from the magnet, right, in the question. Okay, let me know the direction of induced current. What is the direction of the induced current? So you have two options. Okay, either you choose XY, or you chose B, which is Y to X. What do you think the answer is? Don't simply choose lah. You must have a way to get the answer. A or B? The answer is B. Because we use Fleming's right hand rule. Okay, so for induced current, we use Fleming's right hand rule. Alright, remember I'm having a bit of a problem. So first of all, alright, you have your hand, your right hand, right? So this is north, this is south, north and south, so you're pointing it in that direction. And your thumb is pointing away from the magnet. So the middle finger is going up, right? So that's why the answer, so this is the direction of the induced current. So this is why the answer is B, Y to X. I hope this is clear. If you're not sure, please ask your questions in the chat. Was my hands clear? I just thought of another way that I can illustrate the answer. Do you all understand? Do you all need more help on this question? I mean, we are all here on a Saturday morning. You must make sure you understand everything, right? Crystal clear. Okay. Wow. Really? Okay. Moving on. Okay. Students, they find a lot of problem in this topic as well. Let me know what you think the answer is. What do you think the answer is, guys? All three answers submitted, all are different. The first three answers that were submitted. Now look here. You have an LDR. And you have a normal resistor. Okay. You know that when light, we established this 2 days ago, right? When the light intensity, okay, your light intensity increases, right? Your light intensity increases, your resistance goes down. So immediately we know the answer is not C and not D, because we know that when light intensity increases, definitely the resistance of the LDR goes down. Okay, and you know that if the resistance here is decreased, so the voltage across the LDR is less. The voltage across the LDR is less because there's less resistance. So therefore the voltage here increase, and that's why the answer is B. Do you understand? Any problems with this question? Please ask. So if you have a question, please type it in, yeah? Please type it in. Okay, another one. So whenever current is applied, of course they will be asking about induced force. Okay, so this is an induced force, right? Wow. Okay, so in this case you use Fleming's left hand rule, all right? Yeah. yeah, north south, yeah, yeah, exactly in this position. You have north and south, you have current moving here, so the term is the induced force is going up. So the answer to this question is A. So I chose this question because I wanted you all to know the difference between the Fleming's left and the Fleming's right hand rule. So the Fleming's left hand rule, you use it for induced force, and Fleming's right hand rule, you use it for induced current. Did I say that right? Left hand is induced force, right hand is induced current. Right, moving on. Yeah, if this can be a tricky question, be careful. You got to understand all the shapes of magnetic fields, huh? The answer is A. Okay, so I'm gonna draw it out. Well done, Angsin and Elisa, huh? So this is the coil. Okay. Um, okay, look at the question, yeah? Look at the question. So the current comes down here and up here, right? So current, okay, in the front face of the coil will be moving upwards. So can you tell me, right? Yeah, on the left hand side and the right hand side, is this north or south? Is this north or south? Can I see some response first? So can you please type left is north or left is south or right is north or right is south? Can I see some answers? And also share with us, what rule did you use? Okay, yes. Left is north, yeah. What rule? No, Angsin. Right is no. Yeah, but you got Angsin, you got the right rule, but you got the wrong direction, yeah. So it's north and south here. So we use the right hand grip rule. All right, I'm not sure if you can see this. Yeah, so we use the right hand grip rule. Okay, yeah, so we are using the right hand grip rule, and where the thumb is pointing, see, my fingers are following the direction of the current in the coil. So the thumb will be where the north is. So the left is north and the right is south. Of course, the question is not asking this, but we are here to learn not just the question, but to do some revision as well. All right, so inside the coil, all right, well, since this is north, so it will be in this direction, isn't it? So as you exit the coil, it will look like this. And as you enter the coil, you ingress the coil, it will look like this. So therefore, they're asking you inside the coil, it really looks like just horizontal, equally spaced lines, which is why the answer for this question is A. Now, is anyone not clear? Please ask in the chat. Is this clear? Yeah, can be quite confusing, Lisa. So try this now. But thank you for trying. Thank you for participating. We're all here to learn. It doesn't matter if you get the right or, sorry, if you get the wrong answer. It really doesn't matter, okay? As long as you learn, at least you know that something's not right. You got to go back and do some revision, or you can watch the video again much later. Okay, here, so we have a NOT gate. We have, wow, all the answers are coming in already. We have a NAND gate and we have a NOR gate. And so the input here is O and the input here is 1. So for those who are not so sure, I'm going to demonstrate like step by step, yeah. So this is 0, so this is 1. This is 1, here is 1, and here is 1, right? So 1 and 1 is a 0. So x will be a 0. So immediately you know that the answer is A or B, correct? Alright. So if this is a 0, this is a 0. Yeah. And 1 and 0 is a 0 as well. So the answer, you are absolutely right. It is A. No particular reason, because I just felt that in 2 days ago we did not try logic gate, so I thought it's good to jog our memory. Everyone got it right. Straightforward question. So remember your logic gates as well. Okay, so now we have gone to the last topic. We should be ending soon. Just a few more questions. So this is the experiment to establish the existence of the nucleus in an atom. So what do you think the answer is? So definitely you know that in the experiment they used alpha particles, right? So immediately you know that boy and donkey is wrong, okay? Um, so you know, of course, yeah, you are right. The answer is C, because you know the nucleus is positively charged and definitely alpha is also positively charged. So positive charges repel. So the answer is C. Okay. Again, I chose this because not because this is difficult, but because yeah, we did not cover this 2 days ago, and this is quite uncommon to come out in paper 2. All right. So it's good to jog your memory on this particular subtopic of atomic physics. Moving on. Whoa, this is difficult. Now, please think through this question before answering. Yeah, please. What do you think? Not easy, eh? I just checked. This is the second last question. After this will be the last question. Then we will say goodbye. Ang Sin, the first one to throw the dice. Hey, she says. Why is everyone choosing A? Okay. Now, I'm going to explain this question. Now, firstly, when they say upward electric field, I hope you know it means positive here and negative here. So this is what they mean by an upward electric field, and this is what they mean by a downward electric field. Okay. So when they say upward electric field, it means the bottom terminal is positive, the top terminal is negative. When they say downward electric field, it means that the top terminal is positive and the bottom terminal is negative. All right. So they have now told us that the magnetic field is into the paper. So let's test whether A is correct or not. So if it is alpha, remember for atomic physics, so for alpha, all right, so alpha is the same as current. The direction that alpha takes is the same as current. So if it's alpha, we still use our Fleming's left-hand rule. All right. So magnetic field into the paper, and alpha, well, I do not know, but my hand shows that alpha particles should go up. And according to A, it says that there's an upward electric field. So more so, the alpha will be attracted to the top negative terminal. So more so, the alpha will go up. That's how we know that A is absolutely wrong. Does anyone need me to repeat what I said? Do you understand that? Okay, I'm going to repeat one more time slowly. Okay. So this is the upward electric field, downward electric field. Magnetic field is into the paper. So A is alpha particles, right? In the question, A is alpha particles. So we are going to use Fleming's left-hand rule. So the middle finger is current, remember? All right, so the middle finger is current. So alpha is in the same direction as current. So magnetic field into the paper. So your index finger into the paper, and current or alpha is moving to the right. So your thumb is moving up. So the induced force is up. So if the particles were alpha particles, it's going to go up. And if there was an upward electric field, like what the answer recommends, it will go up, really go up. So now, but in the question, you can see that it's going down. So A is absolutely wrong. I hope that was enough. Kenjin, if you want me to go one more round, please say so. Okay. Let's look at B. The source emits alpha and there is no electric field. So for B is also wrong, because if there was no electric field, it will still go up. It will still go up. And in my mind, there's 100 ways of how I can modify this question to make it so much more interesting, right? All right, so wonderful. Never mind. C. So we know it's definitely not alpha, because alpha is going to go up. All right. So if it's going down, definitely it's beta. You know that I don't even have to read and think about C, because D, gamma, is absolutely ridiculous. That gamma is neutral, it's not charged, it's a wave, right? So it's not going to deflect. So automatically I know that D is wrong. So I know that C is the answer. So in the exam, regardless of what C says, you choose C as the answer. But of course, now that we are learning, we are going to go through what C talks about. So let's read. The source emits beta particles and there is an upward electric field, sorry. So upward electric field looks like this, and beta goes down. Is that true? So remember that, well, you can do this many ways. It depends on what your teacher has taught you, right? And in my class, I tell my students that if you want to do beta, right, and if you want to choose the left hand rule, all right, then you got to remember that if you choose left hand rule, remember this is alpha, so whenever you see beta, you just reverse the direction. Okay, and I also told my students that you can also use the right hand rule. So if you use the right hand rule, then this will be the direction of beta. So for this, you can use whichever. I'm going to use the right hand, right? So magnetic field into the paper, and yeah, you're not going to be able to see this because my hand is covering. Yeah, so I'm going to use my left hand because that will be more visible for the camera. So magnetic field in, and I'm going to move my middle finger to the left because it's the opposite. Okay, it's the opposite of alpha, so my thumb is pointing down. So correct, beta will go down. You don't have to do this exercise actually, because if you have established that alpha goes up, beta goes down, right? So beta goes down and there is an upward electric field, so beta will also be attracted to the positive terminal. So the sentence has two parts. Okay, if it is beta, it will go down, and if it was electric field upwards, it will also go down. So irrefutable that C is the answer. Do you all need further explanation on this? So this is an amazing question. Amazing. And the fact that they had D gamma radiation there, it really helps you to increase your chances of getting it correct. All right, any questions whatsoever? Okay, Elisa, I got your question. How do we know it's an upward electric field? Now, you have to understand that electric field is the direction, yeah, electric field is the direction of force on a positively charged particle. All right. So, if you put a positively charged particle here, where will it go? It will go up, right? That will give you an indication of the direction of the electric field. All right. So upward electric field means the arrows are like that, and this arrow represents force on a positively charged particle, and that can only be true if the positive terminals at the bottom and the negative terminals on top. All right, so I hope you know whenever they give you a positive terminal like that and a negative terminal like that, I hope you know how to draw the electric field lines, right? All right, the electric field lines are like that. So in this case, we say that the electric field is to the right, a right direction electric field, right? Okay, Elisa, I hope that's clear. Huh? And guys, remember, if there's any questions after this, we are always reachable. Our number is there, our Facebook, Instagram is there. You can drop us a message, or WhatsApp will be fine. It's the fastest one, right? Like, who checks Facebook anyway? Who checks Facebook, right? Moving on. Last question. It can be a bit confusing, so please read carefully. So very clearly there are two new types of nucleus here, yeah. So you have the iodine 131 and you have the xenon 131. So this is unstable, it decays and produces xenon 131. So what do you think the answer is, guys? Half-life 8 days. I see your answers. Okay, now one thing you need to understand is that there will not be a, I mean, if you keep on dividing by 2, you will never get 0, right? Now, theoretically, if you keep on dividing something by 2, you will never get 0. There will be still some amount left, albeit very small. Okay, So you will still have beta particles emitted. So the fact that no more beta particles are emitted, wow, that's a very far-reaching statement. I would say that A is not the answer. Let's look at B. After 8 days, the number of xenon 131 has halved. So B is also wrong. Can you change that sentence? Which word is wrong? Can you change it and make it right? Can you make B right, please? Can we now all together, can we make B right? No, I think it'd be too complicated. Sorry. Let's forget about that. Let's forget about that. Yeah. So anyway, after 8 days, the number of xenon will not, assuming that there was no xenon to begin with, you're going to have a certain amount of xenon now, right? Which is half the amount of iodine, right? Okay. So B is absolutely crazy. It's wrong. C, after 16 days, how can it decay completely, right? I've just established that no matter how much you divide, you're not going to go zero. So C is also wrong, and that means D is the answer. Let's read. After 16 days, the number of iodine 131 has reduced to 1/4. Definitely, right? If you have 1 to begin with, after one half-life, you got half, and after another half-life, so 8 days, 16 days, you're going to get 1/4. Therefore, D is the correct answer. Well, we have come to the end. Okay, remember this is your syllabus, 5 topics. We have gone through key questions on all 5, and I've gone through what I could. So, well, that's the end. If you have any questions, please key them in the chat. The chat is still going to be active for a few minutes. All right. If you have any questions about this or any questions about unrelated questions, you can please key them in. But officially, the session has ended. And thank you for watching. Thank you for supporting Aspiration International School. And do hit the subscribe button for more videos like this in the future. Remember that if you're taking chemistry, we're having a session on Monday at 3 p.m. Okay. So thank you very much and all the best for your exams. All right. So we're going to go to the chat now. Thank you. Bye-bye. Thank you.